Hello everyone. Hello everyone. Today we will discuss reactance type distance relay under the lecture series of transmission line protection. So last lecture we will discuss about the impedance relay. The working principle is quite different from impedance relay. So today we will discuss the reactance relay is basically a such type of relay which speed is very high, and about if we talking about their construction, so it consists of two units: an overcurrent element developing positive torque and a current voltage direction element which either adds or opposes the overcurrent element, which is depending on the phase angle between the current and voltage. It means we can say that a reactance relay is an overcurrent relay with directional restraint. The directional element is arranged to develop maximum negative torque when its current lags behind its voltage by 90 degree. The induction cup or double induction type structures are best suited for actuating reactance type distance relay. So basically we will here study about the induction cup structure of reactance relay. As shown in figure, it has a 4-pole structure. This one is one pole, two pole, three pole and four pole. So 1, 2, 3 and 4 pole. So it has basically 4-pole structure carrying operating, polarizing and restraining coil as we shown in the figure. The operating torque is developed by the interaction of flux due to current carrying coils, that is, interaction of fluxes of poles 2, 3 and 4. And the restraining torque is produced by the interaction of fluxes due to the poles 1, 2 and 4. This is the orientation of flux produced or torque produced. Thus, operating torque will be proportional to I square, while the restraining torque will be proportional to Vi cos theta minus 90 degree. The desired maximum torque angle is obtained with the help of resistance capacitance circuit as illustrated in this figure. This is the resistance capacitor circuit. This is resistance capacitor circuit. This circuit is used because we want to maximum torque angle with the help of this resistance and capacitance circuit, which is used with this structure. If the spring control effect is indicated by minus K3 as shown, same as shown in the previous lecture of impedance relay, the spring control effect is minus K3, then the torque equation becomes T equal to K1I square, that is the torque which is proportional to I square, and the torque K2 Vi cos theta minus 90 degree. This is the restraining torque which produces by while pole 1, 2 and 4, and minus K3. This is the torque due to spring used in our structure. Now earlier we will know that when theta is defined as positive when I lags behind V, and in earlier lecture we will know that at when balance point is occur or equilibrium point is occur, the net torque is equal to 0. So here we will provided net torque equal to 0, then put this equation here, T equal to 0. That means after mathematical simplification we find out the equation Z sin theta equal to K1 upon K2. And if we talking about the reactance part, so we all know that the impedance is written as Z equal to R plus JX. X is the reactance, either capacitive reactance or inductive reactance, but in terms of trigonometrical terms, we will say that Z equal to A cos theta plus I sin theta. So here we will show that the cos theta plus I sin theta, and that means reactance part is equal to the sinusoidal angle of theta. So here z sin theta equal to k1 upon k2. That means this part is known as the reactive part of the transmission line or of the mathematical expression. So here reactance is equal to k1 upon k2. k1 upon k2 is again a constant. That means in reactance relay, reactance is calculated which is depends on the constant part. This equation is achieved when we consider the K3 is equal to 0. That means we consider the spring control effect is neglected. At that condition we find the equation z sin theta equal to k1 upon k2 or x equal to k1 upon k2 by relation of impedance to the in trigonometrical form. Now we are talking about the operating characteristics of an reactance relay. So here we will see that the characteristics of a reactance relay will be such that for all the position of the impedance phasors whose heads lie on these characteristics will have constant reactance component. That means the characteristics will be straight line parallel to r axis. This is a straight line parallel to r axis. Now x is the reactance of the protected line between the relay location and the fault point, as same as the impedance relay, where z is the impedance of the protected line. Here reactance is the protected line, x is the reactance of the protected line between the relay location to the fault point. The significant point about the characteristics is that the resistance component of the impedance z equal to r plus jx, so this part r part of the impedance has no effect on the operation of the relay. The relay responds only to the reactance component. Any point below the operating point, this is the operating point below and this is the above. So if you are talking about any point below the operating point characteristics, whether above the or below the r axis will lie in the positive torque region. This is the positive torque region. That means below of the operating characteristics, this region is simplified as the positive torque region. And if the value of tau in the general torque equation T equal to k1 I square minus k2 vi cos theta minus tau minus k3 is made any other than 90 degree, a straight line operating characteristics will still be obtained, but we can say that it will not be parallel to r axis. Such a relay is called as an angle impedance relay. So the relays, as can be seen from its characteristics, is a non-directional relay. It is not capable of discriminating when used on transmission lines whether the fault has taken place in the section where the relay is located or it has taken place in the adjoining section. The directional unit used with the reactance relay will not be same as used with the impedance type of relay because the reason is that the reactance relay will trip even under normal operating condition or near unity power factor. This is so because the restraining reactive volt amperes in that case will be nearly equal to 0. Therefore, the reactance type distance relay needs a directional unit that is inoperative under normal load condition. This is the major drawback of reactance relay. It required a directional unit that is inoperative under normal load condition because it can be operated during the healthy condition. The type of the unit employed for this purpose has voltage restraining element which opposing the directional element, and this type of relay is now known as the admittance relay or Maha unit of relay or Maha relay. And this type of relay we will discuss in later section, which is our topic is Maha relay. And reactance type relay is basically suitable as a ground relay for ground fault because its reach is not affected by fault impedance or arcing resistance. So reactance relay in this section in operating characteristics curve we easily see that this is basically operating characteristics. Below these characteristics the positive torque, upper this characteristic is negative torque, but the region is The drawback of this reactance relay is that it is it cannot be capable to discriminating the fault which is occurs in our protected zone or our above the protected zone or outward to the protected zone. Due to this, we need to connect the directional unit in this type of reactance relay. So in positive torque region, the relay will operate, and when the negative torque region, the relay will be not operate according to their operating characteristics of reactance type distance relay. The modification is used in this type of reactance relay is to using the directional element, and it is called an admittance or Maha unit. Maha is basically unit of admittance, so it is also known as admittance unit or Maha unit, and this will be deal in forthcoming section. So now further lecture we will discuss about the Maha relay, and we will discuss how it Maha relay is overcome the drawbacks of the reactance relay. So thank you very much to watching this lecture.